Right, good morning, everybody. I hope people can hear me. Maybe somebody can.
Yeah, I can
good.
hear you loud and clear.
So welcome to this ARCHER2 course aimed at software developers. I see there are a few more people just coming in as I speak. So I'll make it a slightly slow introduction. Hopefully you've all found the link to the course material, which is on the ARCHER2 website training page, or the link is there, and the material should look like this. Okay, if anybody has any problems with any of this, please just drop a message into the chat or say something, and one of today's helpers, who are Julian Sint, maybe want to say hello, Julian.
Hey everyone.
And Quevin is also here, I think.
Hello.
Right, good. So if you have problems, they will be on hand to help. Giving the presentation, I'm in not such a good position to see the chat, so please do or you can just switch on the microphone and shout at me if you want to have a question. Okay, so here's the outline of the material. Is this font too small for anybody? Would anybody like the font to be a bit bigger on the screen?
It looks good to me.
Yeah, okay. Again, I'm going to do a bit of flip-flopping between the material here, which you can either follow on the screen or via a separate web page, and my terminal, which is over on the right-hand side. Hopefully that won't be too disconcerting. So the name of the game today is to try to just provide some orientation for folks who are just starting to use ARCHER2, and we have an assumption that most of you will be familiar with what's going on these type of systems. Just as by show of hands, perhaps, is there anybody who's not used ARCHER1? Nobody's claiming to, so I'm expecting probably most people have used ARCHER1. So a lot of this should be looking quite familiar to you, but there are some significant differences between ARCHER1 and ARCHER2, and so we'll have a look at what those are over the course of the day and tomorrow morning. So the basic aims are here. We're just going to get logged in, make sure we can do that, and have a look around to see what tools and applications are available in the standard system, how to submit jobs, and so forth, and one or two extra words on how to check your resource usage and things like that. So you should hopefully all have a laptop. I don't mind whether it's Linux or Mac or Windows or whatever. I suggest you just do what you would normally do, and we'll have a look at the process for logging in just in a minute. Hopefully there are no accessibility issues today. I should note that I am at home today on the end of a mobile phone, basically, so I've not switched the camera on to try to preserve what bandwidth is available. So hopefully that should hold up. So here's the schedule. The first thing we're going to do basically is to make sure we can all log in with our passwords and SSH keys. We'll then have a look at an overview of the system, what hardware and software are there, some material aimed at people who are interested in developing code, so compilers, tools, etc. What's available and how to use it. Lunch should be at approximately 1 o'clock. This schedule is not set in stone, but we will try to keep the start times after lunch will be 2 o'clock. The scheduler section will probably be a bit longer than 40 minutes, and in the end we'll probably put off debugging and profiling until tomorrow morning, and I do want to try to finish by 4 o'clock this afternoon. So today's session should not go on beyond 4 o'clock. And tomorrow morning we have the last session, which will start again at 10. Any questions on all that before we get going? Okay. So first item on the agenda is logging in. Hopefully you're all reasonably familiar with this in the context of ARCHER2. So you should have received an email asking you to apply for an account, and I have okayed all the accounts I've received requests for so far. Please let me know if you're still pending an account, but that should have allowed you to connect to the safe and retrieve an initial password for the machine, and you should have also uploaded an SSH public key. So the login address is there. It's login.archer2. The all-important 2 is there, .ac.uk. And when you log in, you will first be asked for your machine password and then your SSH passphrase. I'm going to demonstrate this in a moment, just when we've had a look at the password policy. When you first log in, you'll be asked to log in the password, log in with the machine password that you've retrieved from safe, and then you'll automatically be asked to change this. So you need a new password. And there is a policy, which if we follow this link here, we can have a look at the policy. which is basically as follows. There is a minimum password length of 18 characters, but then you basically get a discount in length for adding complexity to the password. So if you have various combinations of upper and lowercase characters, you can get away with a shorter password by 2 characters. If you use some numbers, you can get away with a shorter password still. And also there is a 2-character discount for use of some punctuation or special characters. So in effect, you get a maximum length of something between 10 and 16 or 18 characters. If you're ever in the situation where you need to change your password, there is also some additional conditions on basically your new password should not look like the old one. Hopefully that's all fairly standard stuff. So here's a little quiz which is asking us to say which of these passwords would 1 be a valid choice and 2 be a good choice according to the policy. So you may want to take a few seconds to have a look at each of these. So hopefully nobody is thinking number 1 is a good password. That has only lowercase characters and so is too short at whatever it is, 10 characters. The second one, this looks like a good password to me, although it's only lowercase characters. There are 7, 12, 16, 19 characters in rainbow llama jumping, so that was that should qualify. Gentleman from the National Cyber Security Center was interviewed on the radio the other day and was extolling the virtues of 3 random words as a memorable password. So that's an example. Number 3, slightly more tricky, that one. If you count up the characters 1, 2, 3, 4, 6, 8, 10, 11, because that has both uppercase, lowercase, numbers and some punctuation, that should meet the complexity requirements and the length requirements. So that's a decent password. The 4th one, this horse battery staple, looks rather similar in form to number 2. However, while this is a valid choice, it may not be a good choice. And the reason is, if you're a fan of XKCD comics, you will recognize that as a well-known combination. So a little care is maybe required in some of these passwords. Okay, So let's put this into practice, and I'm going to, so I have created myself an account in today's temporary project, which is TA 015, which you all should now have done. So what I'm going to do is try to go through the login process in my terminal over here. So hopefully everybody can see this as well. So what one would normally be expecting to do, so here I am, I'm on a Mac as it happens here. So this is Unix-like from the terminal, and we would normally expect to SSH. My account name is whatever it is. I give my account name my initials followed by the project. Not to remember, archer2.ac.uk. So we may think about typing something like that, but we also need to let SSH find the appropriate public key. So we have to give SSH some more information. So at least on the Unix-like side, people should have a directory in the home directory .ssh where SSH keys should live. Mine looks like this. So in here I have a load of SSH key, public and private key pairs. So the relevant one for me is this one here, which is the public part called ID RSA login Archer. You see, that's the public part. Its permissions are read for user, group, and everyone, and the corresponding private part is here, and that has that's indeed private. So one of the problems that can occur is those permissions on those public and private keys must be exactly so, or else SSH will refuse to recognize the key. Okay, so given that, I should be able to tell SSH what my key is, and it's ID RSA. So this is this -I option to SSH, the so-called identity file is this, and this is my user account at login.archer2. If you're there, you should just go ahead and do this if you're happy with all this. You can now, and hopefully people can start to log in. You can just now laugh at me trying to type my password. So here's the first prompt is the machine password, which you should have recovered from safe, which will be some horrible string of random letters and numbers, which I'm going to hope to get right. No. Oh yeah, oh success, right. So the first thing you will be asked to do is change your password. So you've got to put in the that safe password. It's come from safe again. And a new password, which I'm going to select one appropriate with our policy in mind. And retype the new password. Okay, that should hopefully work. And then you need the passphrase that is associated with your SSH public key. That's not correct. Okay, so it's just log me out. That is a feature the first time, so let's go again, put in our new password. It seems a little slow today. Here's our SSH passphrase. Okay, and right, hopefully when you log in, you'll see this this banner. I'll just make this window slightly bigger, perhaps. You'll see this banner, and you've logged in. Right, okay. So, how are we getting on? So, hopefully, everybody can try that. And is anybody having any trouble with that? So someone's, I'll just check. We have no accounts pending, which should be over here. Yeah, okay. I'll just, there's a couple of people, Eric and Peter are just pending. I'll just accept those now. So this is what I get to do at this end. And when the account's gone through, you should just get an email. So the line just before I logged in. So the other thing I should mention here, there's also where's it gone? It's here. There's also a Scratch workspace page associated with this course where you can dump information. I'll stick the link into the chat in the there. So if you have bits of information that might be useful, we can put it into that link. So Helen asks, the line just before I logged in, I assume by this you are meaning this SSH command. I'll stick that into the, oops. Stick that into the, chat there. Okay, perhaps by show of hands, who's logged in? Okay, well, quite a few. If you're having trouble with anything, please let us know, and we'll allow just a couple more minutes for people to manage that. Hopefully those accounts, is anybody else pending an account? I don't think so. Is anybody? Don't think so. Okay. Okay, I'm going to just log out again, so I'm back on my laptop. The other thing that can be useful, so you can go through this process every time. Some people like to use password managers and so forth to help with this process. I am slightly becoming a bit of a dinosaur in that I try to remember all my passwords in my head, which is increasingly untenable. But the one thing I do for SSH connections, if we have a look in my .ssh directory, I have a config file here. So if we have a look at this, oops, there's my typing gone to hell again. If we have a look at that, we have here a load of entries for various machines. Here's the one, here's the entry that's relevant for ARCHER2. So this has a series of statements which allows SSH to do things automatically. So this is saying for login anything archer2.ac.uk, this so-called identity file, or the relevant private key here, is this one here. So that's what I was using in the -i option. My normal user account name is Kevin, so that's the account name I would usually use. There's some other stuff here which what this is doing is allowing me to basically authenticate once, and then I can piggyback future connections off the first SSH connection. So that means I only have to authenticate once per day. And if you're doing a lot of things like scopy to and from ARCHER2 in this case, that can be useful to prevent yourself having to authenticate each time. X11 forwarding, if you're using X11 applications, that can be required. Not very useful for me here at home at the moment, it should be said. This one again, because I'm on the end of a mobile phone, effectively I have this line here to basically keep the connection alive if I'm idle for more than a minute or two. So that can be a useful thing. So I'll stick that into the scratch pad as well, if you're interested in it. So that's that. Hopefully, so you can have a look at that if you're interested in that method. Okay, anybody still struggling to log in or not received their initial account yet? Oh, okay. Okay. So someone has an account. If you have an account, or if you have an account from a previous course, that should still be okay. Yes. Or if you want to if you want to use if you have a standard user account, you can also use that if you so wish. Okay, so hopefully everybody, or more or less everybody, is now got logged in. So the first thing one might want to do is to shift some data around. So there are pretty standard ways to do this. Classic way is scopy. rsync is also becoming increasingly popular to keep files synchronized between different locations. Now here's a question: has anybody heard of Globus? Okay, Hannah's just managed. Okay, someone will come and help you, Hannah. So I suspect nobody's heard of Globus, so I won't say anything about that. So the other thing I should say in the context of ARCHER2 use is those standard mechanisms, scopy and rsync, are appropriate if you want to shift data between ARCHER1 and ARCHER2. The only thing to note is that there is a special route has been set up between ARCHER1 and ARCHER2, which has potentially higher bandwidth and that route is associated with a different endpoint. So maybe one of the guys who's helping can paste that into the chat. I can't remember just off the top of my head, but that's documented in the relevant places. So if we're moving data around, it's worth actually just spending a bit of time trying to think about data and whether you need to move data at all, and how important is your data, i.e. does it need to be in a secure location? Can you afford to lose it? Can you regenerate it at low cost? And so on and so forth. So formally, if you're involved in a project, you might even have a data management plan, which is the formal route to specifying what you're doing with your data. So fairly obviously, one would like to try to minimize your data transfer. So think about only transferring stuff which you really need. So in doing this, you may want to think about minimizing the number of files you are transferring. So there may be a small overhead for transferring a file at all. So if you have zillions of small files, it would be better to perhaps try to bundle those up into some kind of archive file and transfer a single archive, which may or may not be compressed. Again, for compression, there's often some trade-off between how much you are gaining in terms of making the data volume smaller and actual time taken to do the compression and decompression at all. So you may want to think about that. The other thing to be aware of when using secure copy, as its name suggests, it is a secure method which involves encryption. So again, there's an overhead to that encryption, which can be addressed to at least some extent by choosing a relatively fast cipher, which can be set as an option to SSH. I think there's some advice on that as well for those of you transferring data from ARCHER1 to ARCHER2. So here's a bit of an exercise. If you have some data on your laptop or your local machine, you can think about trying to compress it up into an archive. You can use either zip or you can use tar if you're familiar with tar, and then try and scopy the file onto Archer. Okay, I'll give you a couple of minutes just to have a look at that. In the meantime, anybody still not logged in, again, please let us know somehow and we'll help you out. Or as I say, any questions, just dump them in the chat and yeah, Evgeny state is the Globus toolkit from the grid computing days. Yes, exactly so. You're showing your age already. Yep. Okay, so maybe folks have had a chance to have a bit of a go at this. The other question which is asked here is for zip. I think it is possible to verify that the archive file is correctly formed, which can be a useful thing, as it can be slightly embarrassing if you tar up some data for archive purposes and then come back in, delete the original data and then discover you have a badly formed archive file. That's slightly embarrassing. So I think the solution here for zip is -0 for no compression and -r to perform this recursively on directory structure, and -t option will tell you whether you have a correctly formed archive file for the case of zip. Okay, so I think that hopefully we've got everybody logged in, and we can now think about going on to do something. So I am spectacularly on time this morning, and the schedule calls for a break now for tea or coffee or whatever you like, and we will come back at 11:20 to have an overview of the system. If you're still struggling to log in, someone will stay around here now to help you out, to make sure everybody's logged in. So unless there are any questions, we'll now have a break until 11:20. Okay, I think now modulo 1 or 2 remaining issues, everybody's managed to log in. I just okayed, I think, one more account a couple of minutes ago. So again, somebody will help you log in. If you're having trouble, please type in the chat and somebody should dive in. But I will now move on to the next bit of subject matter, which is basically an overview of the ARCHER2 system. Unless there are any pressing questions from the previous material. If not, let's go on to the ARCHER2. Okay, so ARCHER2 is another Cray system, following on from ARCHER1. The architecture is referred to as Cray Shasta. The exact configuration of the system is something of a movable feast just at the moment. So it's not in its final state. So some of this material should be taken as the ideal view of the final state, which we don't have quite yet, but I'll try and point those things out as we go along. Basically what we have at the moment are a series of login nodes, well, in fact, 2 login nodes. So if you've logged in, you should see in your prompt you've logged into either UAN01 or UAN02, user access node 1 or 2, and that which one you get is basically random. And there are a series of compute nodes which form the workhorse of the system. So one of the first things that's different from ARCHER1 is that all the nodes, both the login nodes and the compute nodes, are of the same architecture. So on ARCHER1 there was a rather unfortunate situation where the login nodes were a different architecture to the batch or back-end nodes. So that gave some additional complexity in terms of things like cross-compilation. In the new ARCHER2 system, those concerns are largely eliminated because the login nodes and the compute nodes are identical. So that is one thing which is more simple on the new system. So the basic nodes are formed of AMD EPYC cores, and there are 2 64-core sockets per node, so 128 physical cores per node. So there's a sort of schematic picture here. So when you SSH in, you're sitting on the login nodes, and you communicate with the compute nodes via the batch system, which is on ARCHER2 Slurm. We'll come on to talk about that this afternoon. So the other resources available, we have some disk space. So there is a so-called home file system /home, which is only visible from the login nodes. So I may fall into the jargon of referring to the login nodes as the front end and the compute nodes as the back end. So that's what that means if I use those terms. Most of serious computational activity will take place on the back end or the compute nodes, and these have access to a /work file system, which is the Lustre high performance file system. So to run jobs, basically you should be in /work and not /home. So hopefully that's familiar from ARCHER1. Again, there's a couple of things on this picture. These so-called data analysis nodes don't exist yet, and also the solid state storage is not available yet, but is slated to be so in the final system. So that solid state storage is intended for what's sometimes referred to as sort of burst buffer or in VRAM type activity, where you have a relatively small amount of fast disk, if you like, close to the compute nodes to hold frequently used data. But we'll have to provide details of that when it becomes available. So again, these stats here are for the final system. The final system should be made up of some almost 6,000 compute nodes, which would provide about 750,000 cores. At the moment, we're only at about 1,000 compute nodes, so the total capacity is somewhat reduced until the remaining bits of the system arrive from the United States, and I believe they're being scheduled to be shipped over to the UK in February. So each node has about exactly 256 gigabytes of memory. There is provision again in the final service with high memory for high memory compute nodes with 512 gigabytes, but again those are not available yet. So all the nodes are linked on the back end with the high performance network, which is called Cray Slingshot in this picture. So here's just a little table which is giving a sort of a comparison of ARCHER2 and ARCHER. So the notable things there are that the number of cores per node is a significant increase from 24 to 128. And as batch jobs are all to use whole numbers of nodes, you should be thinking in terms of running at least 128 cores as a sort of minimum problem size. So the slightly, in terms of architecture, the slightly larger nodes in terms of the number of cores are also reflected in a difference in the NUMA architecture. So whereas there were 2 NUMA regions per node in ARCHER, so 12 cores per socket in that ARCHER1 picture, there are now 8 NUMA regions per node with 16 cores per NUMA region. So if you're interested in things like mixed MPI and OpenMP codes, you should be thinking something like 16 OpenMP threads per MPI task. It may be the limit of good performance there. The total memory can be viewed as an increase per node, but actually, if you do the arithmetic, it's a slight decrease per core. The other important parameter for many scientific codes is the memory bandwidth. That is, how much data can you push between the processor and main memory in a given time. So the figures we have were about 120 gigabytes per second per node on ARCHER2. That's something like something over 3 times that on ARCHER2. And again, there is a bandwidth associated with the interconnect, which has a slightly better performance than the ARCHER1 equivalent. Okay, so a slightly closer look at the storage. I think the best thing to do with here is just to log in and have a look around to see what we've got. So I'm going to try and log in again. I don't remember what I'm called. Yes. What's my account? No. Does seem a little slow today. Okay, so here we go. When we're logged in, I've landed on UAN 01, user access node 01, and I've landed in my home file space / home. So the form of the directory structure is /home, then the project name, and what is then the so-called sub-project, which for us is TA015 today, and my user account name, which is KS TA015. That's hopefully everybody is familiar with that. So there is a quota associated with the home file system, which off the top of my head I actually can't remember what it is, but it's some relatively small amount of space. So typically one would keep their files of high value, which you wish to be the home space is actually backed up for disaster recovery purposes. So it so happens here that this sub-project is the same as the project. Some of the consortia or some of the projects may wish to define sub-projects. So for example, project T01 might have a sub-project T01 RSE, which would be reflected in that directory structure. So that's all hopefully familiar. So as I said, most activity will typically take place on the work file system, which is /work, and the same structure TA015, and then the sub-project TA015 for us, and then your account name, which for me is this. And you've landed on the work file system, which is there. So ultimately, when the whole system is there, that should be some 14 or 15 petabytes of file space. Again, your project will have a quota in the work file system for which there is an incantation, which we'll see in just a second. So one of the classic problems, particularly from people starting out, is to forget that if you're running jobs, you need to be in the work file system because the back end can't see the home file system. So that's sometimes a bit of a mistake. If you want to see, here's the command here for here this LFS quota minus HG will give us the group quota for us, and the group is TA015 on /work, and that will tell us this particular project has some 50 gigabytes of space. Likewise, there may be quotas per user to examine which you use the -HU option, and then my user account is this one, and it looks like not much is going on there from the user quota point of view, but so it's up to your project managers to set quotas and so forth at a group or a user level. And that's one way you can have a quick look at the current state of the quota. Okay, so obviously for this account, there aren't many files yet. Again, I said the solid state storage isn't available yet, so I won't say anything more about that. Again, one thing which is similar to ARCHER1, if you wish to share files, there are in both the home and the work directory structures shared directories. So if we wanted to share a file with another member of the TA015 subproject, we could put it there. So if I was to create a file in my disk space, I could make that available to all you, because we're in the same project, by moving it to this shared directory. So you should be able to confirm you can see that file. It's not a very interesting file, but the person who created it may wish to check that the permissions are correct so that everybody can read it. I think there's a appropriate chmod command is down there. So if you're moving a whole directory, you might want to check that the permissions are correct for everybody to read for all the files. So -R for recursive, and this incantation is saying that the group should be group permissions should add read and execute permissions, and others, i.e. everybody else, should not have read, write, execute permission. Hopefully this is all fairly familiar. Likewise, so that's within the project. If you want to share data with anybody else on the system, irrespective of project, there's another shared directory one level in the hierarchy further up with the same name, and you can put files in there. Okay, so I think that's basically what's that saying. Okay, so in terms of software, this is obviously a Cray Linux environment, which is based on SUSE Linux. So what we've got are things like compilers. Let's go back over here for the time being. We've got GNU compilers, Cray compilers, and because this is AMD machine, we now have AMD compilers, which is the AMD Optimizing Compiler Collection, AOCC. We do not have Intel compilers, as this is not an Intel machine. MPI is Cray, MPI-CH essentially. The other parallel models of communication are SHMEM and global arrays, if you're interested in those. Our standard numerical libraries, BLAS, LAPACK, SCALAPACK are available by default. We'll have a look at in a bit more detail at this in the next talk. Debugging, which we'll have a look tomorrow morning, is via GDB. Unfortunately, in my view, we've lost access to DDT. So we'll have a look at that tomorrow, and profiling is largely via CRAPAT, which some of you may be familiar with from ARCHER2. Python, anybody doing Python? My show of hands, as a matter of interest. Nobody doing Python. I know a couple of people doing Python. Python is Cray provide an optimized Python 3 environment, which includes NumPy, SciPy, MPI for Pi, and Dask, if you're familiar with that stuff. There is also Cray also provide R, which is a statistical package for statistical problems, if you're familiar with that. So there's just I think I've covered most of those points. The one thing to note about Python is we'll not be supporting Python 2. Okay, for those perhaps more interested in applications, there's a set of standard applications are provided centrally for use, some of which require licenses, others of which are free to use. For those of you coming from ARCHER2, licenses, if you have the appropriate license registered for ARCHER2, that should just carry across to ARCHER2, in that we don't need you to provide the license details again. You will still have to request access to the appropriate Unix group via the safe if you want to use one of these licensed packages. Okay, so I think that's the end of this particular section. I think if we were running a physical course, we might encourage a little discussion at this point, but perhaps if anybody has any questions, I can take the questions at this point. There's a question in the chat saying, do we know much about the proposed data analysis nodes? I suspect they'll just be the same nodes, as Michael says, as all the others. They'll just be set aside in some way for a particular purpose. Okay, well, which is better of the shared directories depends on purpose you want, whether you want to share with either your group or the whole world. Does Cray MPI support F2008? There's a good question. I don't know the answer to that, I don't think, but maybe somebody else does. I don't usually try because nobody supports it, but yeah, it might be worth trying again. Stuart asks questions, will the data analysis nodes run MATLAB? There's a good question. I'm going to do a slightly, I don't think we have MATLAB available at the moment. And I don't think we have any plans to make a license available. So while that is possible, I don't know the answer, but we can probably find out. Okay, there's the official response is the MATLAB licenses are pale. Okay, so Evgeny, will Phoenix use Dolphin X? Is Quevin still around? He may be able to answer that. Doesn't sound like it. That's a question for Quevin, I suggest Evgeny. Julia, will Julia be supported? I think, well, there may be a discussion there as to what supported means, but I don't think there is any reason why it shouldn't be made available if it's wanted. It's not something we have a lot of experience of. Okay, let's just see how we're doing. On the schedule, I'm just going to suggest we just take a short break until 12:05, and then I'll go on to say something about more about what software is available and how you get at it by looking at the development environment. So that will come. That's be about a 5-minute break just to let people have a chance to cover. Okay, I hope everybody is now back from brief break, and without further ado, we'll move on to look at the ARCHER2 development environment, which should take us up to lunchtime. Okay, so here we are. As a developer, we're interested in things like compilers and so forth. So how do we go about getting hold of this stuff, and what do we need to be aware of? Okay, so the first thing to be aware of that ARCHER2 is using a module system which, while similar to that of ARCHER1, has some important differences, which we'll see in the course of this talk. So without, if you wish to see which modules are loaded, we can do module list. So these are the defaults. There is a module here which which looks like something to do with programming environment Cray. CCE is the Cray compiler environment. And there's a load of other stuff here. So it's x86 Rome is the code name for the AMD architecture. libfabric is related to the network, as is this OFI, Open Fabric Interface, and there are some other stuff down here which gets loaded by default. Here's Cray MPI CH, and also by default you'll see here is Cray libsci, which contains BLAS, LAPAC, BLACS, and SCALAPAC. So those happen by default. There is also some further modules down here which are basically convenience things to allow other modules to appear. So those are the defaults. You can, if you start changing things around and you like doing things like module purge, you can get into a bit of a fix, but there are ways of getting out of it, which we may discuss a bit later. So those are the modules which are loaded. To see what's available, just hit module avail. That kicks up quite a big list. So you can now start to see the sorts of things that are available. The first thing we see up here is actually some machine learning type stuff. Can't believe anybody could be doing machine learning at all in this day and age, but there you go. So there are different sections here. So this is Python environments supported by the CSE Computational Science and Engineering Support Team. There's something here, Python modules, Python netcdf4. Utilities are here. So there are things in here like CMake, TCL, TK, if you're familiar with those. Also note this thing XTHI, which we'll come back to later on this afternoon. So one of the things to note is for something like CMake, there is a module version which is not loaded by default. There is also, if I do there is also a default CMake, which is living in /usr/bin/CMake, which is something like version 3.10. To get hold of the module version CMake, I better type correctly, module load CMake, and that adds to the path the location of this module version of CMake, which is, what did it say, 3.18 point something, I think, was it? 3.18.4. Okay, so if you're using CMake, one of the things they recommend is usually to use an up-to-date version. So that may be the one which is available via the module. So if you want to get rid of a module, it's module unload as before. Okay, let's go back to module avail, see what else is available. Oops. There's a series of libraries are available here. If you use things, there's a few more of these are still pending to appear. Here's a section of applications. So this is more things which are applications, things like CASTEP for quantum chemistry, OpenFOAM if you're doing fluid dynamics, and things like this. We should mention that we provide these versions as modules. You can use them if you so wish. We also have available compilation instructions for most of these things. So if you want a special version or you want to compile your own version, we can usually point you at the instructions we've used to build these versions, and you can use those instructions as a basis to do what you wish. So if for any particular requests to install things, we might say, no, we're not going to install them, but we'll help you do it yourself. Other sections here, this perf tools stuff is CRAPAT, etc. Basically, there are a series of modules related to this. There's a whole load of these huge pages, modules related to size of memory pages. There's a few others here which are not particularly interesting. So here are three which we will be interested in. These are the related to the three different compiler collections. I'll come back and say a bit more of those in a minute. There's then a big section of stuff which is supported by Cray themselves. So, for example, Fourier transform, fastest Fourier transform in the West, FFTW, is provided by Cray as module Cray FFTW. Things like HDF5 and NetCDF should be somewhere up there, yes. And various other interesting ones to note I'm looking for. Here is Cray Python. So if you want to have a Python which links to things like optimized BLAS and so forth, and uses things like MPI for Pi, this is the one you should be looking at. Again, there is a default Python in the path, which is not the same as that Python which comes from using that module. So that's one to be a little careful of. Here's GDB, which we'll have a look at tomorrow. Yes. Yeah, I thought we'd yet more, Hugh. Other stuff here. perhaps not so interesting network stuff mainly. Okay, so that's if you're wondering if something's available, that's the way to find out. If something isn't available, please just contact the help desk. We may not install it, but we'll help you do something to make it available. So if you want a bit more information on a given module, so for example, if we load crane CDF, it will give you a bit more information on the exact version and so forth, and any points to note related to netcdf in that case. Actually seems to be an error in the module file there actually. Okay, better write that one down. So hopefully you're all familiar with the business of loading and unloading modules. If you want to have a combination of unload and load can be a swap of modules. So, okay, so modules should look more or less the same as ARCHER1, except in one important aspect. If we wish to, for example, change programming environment, which would on ARCHER1 have been something like that, to change from the Cray programming environment to the GNU programming environment, that will no longer will probably give you a nasty error message because the situation has changed. So the programming environments, Cray, programming environment GNU, and programming environment AOCC for the AMD compiler collection are now are not modules, but rather now what is known as module collections. And the appropriate command to change module collection is this module restore command. So if we hit that, it gives you a rather ugly, apparently ugly series of messages. Basically what it is doing is just unloading all the existingly loaded modules and then loading the new collection, which is basically just a list of modules. So we unload all the stuff related to the programming environment Cray, which that is the module, and we load the module appropriate for programming environment GNU and the latest version of GCC we have, and so forth. So that's the difference. So to go back to, or let's try type programming environment AOCC. This is the AMD optimizing compiler collection. Again, that will now evict all the existing GNU collection and load the AOCC equivalents. So this is the AMD compiler module. Okay, so those, if like me, you're not particularly keen on those messages cluttering the place, you can silence them with the -S option. So if we go back to programming environment Cray, like so, that's slightly less verbose. And hopefully we're back to CCE, which is Cray compiler environment. Okay, so let's just, so if you want within a given programming environment, you can change the exact version of the compiler you have. So for example, in programming environment GNU, we could ask which versions of GCC are available, and that should show us GCC 10.1 is default. 9.3 is also available. I am going to tell you now that you should not use GCC 8.1. It will not be consistent with the other system modules, which are largely installed based on GCC 9.1, in fact. Okay, so I think this is most of this. Yes, okay, so if you then, if you want to swap out the default for a different version, then it's the normal swap. So that's the difference for a module. It's module swap. For the module collections, programming environment GNU, programming environment Cray, etc., it's module restore. Okay, I think this is most of this stuff. Yeah, okay, so if you then want to compile stuff, this is the normal business. If you're compiling stuff, you should be using the compiler wrappers, being FTN for Fortran, lowercase cc for C, and uppercase cc for C++. not the specific compilers. So the compiler wrappers will inject the relevant options required for the modules you have loaded. If you want to see what options are going to actually appear from the compiler wrappers, so for CC, for example, we can issue the command that's not the command. We issue the command -- cray print opt. That will show us the what's actually going to be forwarded to the compiler. So for example, here there's something saying please include the currently loaded libsci include directory there, and likewise the appropriate library paths are added. So if we do something like module load cray netcdf again, and reissue, re-examine what's being generated by oh, I chose this one where there's a problem, didn't I? Brilliant. This is actually indicating there's a problem in the module file, actually. However, what that was intended to show that should also insert the appropriate options for netcdf, but as that looks slightly problematic, we should probably try something else. I'm going to try one which I think I know works. I'm going to try, let's try Metis, which is a library for graph partitioning. So if I reintroduce the option here, you should see this is now included the location of the Metis libraries, and there'll be some equivalent Metis library down there and an include path. So that's actually what's going on when you're using the compiler wrappers in conjunction with the module system. So you don't have to hunt around for all the appropriate options. Okay. Other things to note about ARCHER2, because things have moved on since ARCHER1, systems are generally moving to dynamically linked executables. So for example, some of the system libraries are only available as shared objects, so it's not possible ultimately to do a static link on ARCHER2. This means you may start to be worrying about the location of shared libraries at runtime. However, all the module software should hopefully do the right thing at link time, in that the location of the libraries will be added to the executable image via a run path. So that will be stored in the executable, and you shouldn't need to reload the relevant modules at runtime. Although if there are problems, that may be something to look out for. If you're finding your executable is not resolving certain shared objects at runtime. Okay, where's the chat? Where's the chat down here? Any questions on all this stuff? How are we going? How are we going? Evgeny, conflict if you load Petsy Hyper. I think you just yeah, okay. Petsy Hyper. I'll have a look at that. Let's have a look. Okay, I'll have a look at that one over. I think I know where that may be coming from. The Petsy and the Hyper should be independent, I think. I think that may be a problem, just a bug in the module file. I'll check that out. Matt asks if the compiler wrapper includes MPI automatically, serial binary. My answer would be you need a serial code which doesn't make any calls to MPI. Does that make sense? Oh, so yeah, yeah, you've got to be. So in terms of serial and running serial and parallel executables, yes, there is an issue. So you can run a serial executable in the usual way. For a parallel program, you need to launch it on the back end, as we'll see in the following lecture when we get to Slurm. Okay, so I think there are I think that's about it for this particular lecture. I think the main, just to recap, the main accidents that you can perhaps run into are this business with module restore and module collections. In comparison with ARCHER2. So if there's any questions on this stuff, you can always email the help desk, which in official management terms is now to be referred to as the service desk, but it's the same thing, and we will certainly try to reply with some advice. Okay, how are we doing? So I reckon I'm actually a bit ahead of the game now. So in order to stay on schedule, I'm going to say we'll restart at 2 p.m. With a look at the get down to the business of submitting some jobs to the scheduler. So unless there are, we'll hang around and take any questions that might be arising. Otherwise, we'll come back at 1400.